Good morning, students. In the last episode, we discussed about formula and symbols. Today, we are going to study valency. So, valency means combining capacity of elements. So, valency means combining capacity of elements. So, that is the definition you have studied in the previous classes. So, now there are two more definitions also. The second one is the valency of an element or a radical is the number of hydrogen atoms that will combine or displace one atom of that element or radical. That means the valency of an element is the number of hydrogen atom and element combined. Look at the example. HCl. That means one atom of chlorine combined with one atom of hydrogen. So, the valency of chlorine is 1. Take the next example, H2O. That means one atom of oxygen combined with the 2 atoms of hydrogen. So, valency of oxygen equals 2. Third example, NH3. N means, you know, which element N? It is nitrogen. So, one atom of nitrogen combines with the 3 atoms of hydrogen. So, the valency of nitrogen is 3. I think all of you understood this. That means valency is the number of hydrogen atom and element combined. Example, HCl. One atom of chlorine combined with one atom of hydrogen. So, the valency of chlorine is 1. Then, in water, H2O, one atom of oxygen combined with the 2 atoms of hydrogen. So, valency of oxygen is 2. In NH3 means ammonia. In ammonia, one atom of nitrogen combined with the 3 atoms of hydrogen. So, valency of nitrogen is 3. One more definition for valency. It is the number of electrons an atom lose, gain or share during a chemical reaction. So, the new definition of valency is number of electron an atom lose, gain or share during a chemical reaction. And you know that the elements chemically combine to complete the octet structure. Octet means 8 electrons in the outermost shell, except K shell. If a shell contains 8 electrons, then the element is stable. So, for becoming stable, the elements combine together. So, if an atom loses electron, it will become negatively charged. So, the negatively charged ions are called anions. And if an atom if an atom loses electron, it will become positively charged. Positively charged ions are called cation. So, once again, if an atom loses electron, it will become positively charged. Positively charged ions are called cations. And if an atom gains electron, it will become negatively charged. Negatively charged ions are called anions. Once again, if an atom loses electron, it will become positively charged. Positively charged ions are called cation. And if an atom gains electron, it will become negatively charged. Negatively charged ions are called anions. Look at the atomic structure of sodium. See, The atomic number of sodium is 11. So the electronic configuration is 281. K shell contain 2 electron, L 8 and M 1 electron. So for becoming stable, sodium loses 1 electron. So sodium become Na plus. That means sodium become a cation, and when it loses electron, the new electronic configuration is 2,8 and it is stable. Now it is not an atom, it is called an anion. So sodium become positively charged. Look at the example of chlorine. Its atomic number is 17. That means its electronic configuration is 287. So if it gain one more electron, it will become 288. Then the chlorine atom becomes stable. Then it is called anion. So the new electronic configuration of chlorine is 288. It is stable. So in the case of sodium and sodium chloride, sodium combines with the chlorine. Sodium loses 1 electron and it is transferred to chlorine. So it will become Na plus, and chlorine gain 1 electron and it will become Cl minus. Then it will changes into a new compound NaCl. And look at sodium electronic configuration 281, atomic number 11. Chlorine 17, 287. 287. So this sodium give 1 electron to chlorine. So the electronic configuration of sodium is 2,8. It will become positively charged. And the electronic configuration of chlorine is 288. Chlorine become negatively charged. So negatively charged ions are called anion, and positively charged ions are called cation. And look here, Na. It loses 1 electron and it will become Na plus. So the valency of sodium is 1. Then chlorine, it gains 1 electron, so it will become Cl minus. So valency of chlorine is 1. Then next, oxygen, atomic number 8. Electronic configuration is 2,6. So it needs 2 more electrons to become stable. Stable means 8 electron in the outermost shell except K shell. So if it is only one shell, like hydrogen, atomic number 1. So electronic configuration is 1. So hydrogen needs 1 more electron because it is K shell. But in the other elements, like oxygen, it is second shell, L shell. So if L shell contain 8 electron, it is stable. So oxygen gain 2 more electron, then it will become O2 minus. The electronic configuration is 2,8. Oxygen become, the electronic configuration of oxygen is 2,8. So it is called anion. And look here, oxygen gain 2 electron, then it will become O2 minus. So valency of oxygen equals 2. Another example, aluminium 13. Its electronic configuration is 2,8,3. So it cannot absorb 5 more electrons. So if an element contain 1, 2 or 3 electron, it loses electron. And they are called metals. If an element contains 1, 2 or 3 electrons in the outermost shell, they loses electron. They are usually metals. So metals form usually cations, positively charged ions. So aluminium loses 1 electron. So the valency of aluminium loses 3 electron. So the valency of aluminium is 3. Look here how to write the equation. Al minus 3 electron, it will become Al3 plus. So valency is the number of electron an atom lose or gain or share during a chemical reaction. Another example, phosphorus 15, 2, 8, 5. Or another small example, nitrogen. Atomic number smaller than 2, 7. So its electronic configuration is 2, 5. It is a non-metal. So it gains 3 more electron. Then it will become 2, 8. So N plus 3 electron gives N 3 minus. That means nitrogen absorb or gain 3 more electron, and the electronic configuration is 2, 8. Then it is not an atom, it is an ion. When an atom lose or gain electron, it is called an ion. It is not an atom. So the electronic configuration of nitrogen is 2, 5, and the electronic configuration of nitrogen ion is 2, 8. So it is written like this: N plus 3 minus gives N 3 minus. I think all of you understood how to calculate the valency. So valency is the number of electron an atom lose, gain or share during a chemical reaction. The next topic, variable valency. So variable valency means an atom of an element can sometimes lose more electron than are present in its valence shell. There is a loss of electron from the penultimate shell too. Therefore, such an element is said to be exhibit variable valency. That means, usually, we have studied so many examples. In all these examples, we have seen that the atom loses electron from its outermost shell. But some element like Cu, you know that it is copper, Fe, iron. Elements like Cu and Fe, they loses electron from outermost shell as well as penultimate shell. So penultimate shell means KLM. M is the outermost shell, L is the penultimate shell. So M is the outermost shell and L is the penultimate shell. So they loses electron from outermost shell as well as penultimate shell. So they show variable valency. So there are so many examples. If an element exhibits 2 different positive valencies, we use the suffix OUS to the lower valency and the suffix IC to the higher valency. Like copper has 2 valency, 1 and 1 more valency 2. So this, if the valency is 1, they are called cuprous compound. And if the valency is 2, they are called cupric compound. The same way iron has 2 valency, 2 and 3. If the valency is 2, it is called ferrous compound. And if the valency is 3, it is called a ferric compound. Like, see, CuCl2, it is cupric chloride. CuCl2, it is called a cupric chloride. And so I think you understood variable valency. That means some elements show more than one valency. They lose electron from outermost shell as well as penultimate shell. It is called a variable valency. Example, see, FeCl2. It is called ferrous chloride. And FeCl3, it is called ferric chloride. So next is radicals. Radicals are group of atoms or elements which behave like a single unit. Radicals are group of atoms or elements which behave like a single unit. Like they are acidic radicals and a basic radical. Example, K plus. It is a basic radical. Cl minus. It is an acidic radical. Because Cl minus, it forms hydrochloric acid. SO4 minus, it is called a compound radical. It is also acidic radical. So there are simple radical as well as compound radical. K plus, it is a simple radical. But SO4 minus, it is a compound radical. And see, K plus. That means its valency 1. The number above, the number which is written above, that is the valency. SO4 minus. Valency of sulfate. It is a 2. If the number of oxygen atom is less, it is called ITE. And if number of oxygen atom is more, it is ATE. Like SO3 minus. It is sulfite. SO4 minus. It is a sulfate. So if number of oxygen atom is less, it is ITE, and if number of oxygen atom is more, it is ATE, it is sulfate. And another example, carbonate. It is also a compound radical, carbonate. Its valency is 2. HCO3 minus, it is called bicarbonate. Then NH4 plus, N means nitrogen. These all are compound radical. That means carbonate. It contains 1 carbon atom and it contains 3 oxygen atom, HCO3. It contains 1 hydrogen atom, 1 carbon atom and 3 oxygen atom. NH4 plus, it is ammonium. Ammonium radical. Look the difference. NH3. See the difference. NH3, it is ammonia. It is not a radical, it is a compound. See the difference. Here, ammonium, it is a radical. It cannot exist freely. It will combine with other elements and it can be existed. But see, NH3, it is not a radical, it is a compound. Look here, it has no charge. And ammonium, NH4 plus, 1 atom nitrogen and 4 atom hydrogen. And NH3, it is ammonia, it is a compound. And there are so many examples of these radicals. There are monovalent electropositive, divalent electropositive, trivalent electropositive. See, Ca2 plus, it is divalent. O2 minus, it is also divalent. CO3 2 minus, it is also divalent. Divalent means, what is meant by divalent? Valency 2. Then trivalent, that means valency 3. Al3 plus. See, valency 3. Then Au3 plus. You know which is which element is Au? It is gold. Its valency is also 3. So these are trivalent elements. Then monovalent, that means valency 1. Na plus, HCO3 minus, Cl minus. Look here, 3 examples: monovalent, divalent, trivalent. Monovalent means valency 1, divalent valency 2, trivalent valency 3. So I think all of you understood all these things. That means first we learned valency. Valency means the number of electron an atom lose or gain during a chemical reaction. So there are cations and anions. Cations are positively charged and anions are negatively charged. Then next is radicals. Radicals are group of elements or group of atoms behaved like a single unit. So you must learn all the formulas of these radicals, because if you don't know the formulas of radical and if you don't know the valency, you cannot write the formula of the compounds. So learn all these things. I think all of you understood and learn all the portions I have taught today. Thank you.